Hello everyone, it's my host Cody. Yeah, okay, so hello everyone. Today we start the most important topic there is. It's gonna be about circle theorem. It's probably the most important and hardest general mathematics topic we're gonna do. So we're gonna do circle theorem. Okay, so firstly, I think we should start with a few rules. These rules are just a little hard to remember. Most people don't remember them, but if you remember them, it's pretty easy to do any form um, of these rules. So yeah, let's begin. Starting with what makes up a circle. So let's draw a circle. Yep, there we go. All right. So firstly, we have a center. Center there. We will have a diameter. This line going from one point to the other. That's our diameter. Alright, so we're gonna label that as this is our diameter. Sorry. Right, we have diameter, which is this. Then we have our radius. Our radius is like this line. That right there is our radius. You already know that. Right. What you don't know, or you may know, depending on how much attention you paid in class, this is a chord. It's basically any line going from one end of the circumference to the other. Not one end, like just a line in the circle. That's that right there. This is a chord. This is a chord. That's why I hate enhanced shapes. This bug happens. Okay, so that's the chord. So next, what? The next thing we need to know is a tangent. I'm pretty sure you know what that tangent is. The tangent is a line that's touching the circle at one single point right there. So that right there is your tangent. Right. So let's move on to our next part. So let's just remove this. You can copy this down if you want to, but let's remove this for now. And let's do a few circle theorem questions. Well, actually, no. A few things you need to know in the circle. So let's have a circle again. Let's draw small circles now. I don't want any big circles. So I'm going to draw 9 of these. So let's just draw 9 circles. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so let's start. So the first one is that if we have, let's say, a chord. Chord going from here. Just the lines. Not much better. Alright. Say we have a chord, and we have a line going from the center, and it's just touching the chord, like so. Then, and divides the chord in 2 identical halves. This angle right here, this is going to be 90 degrees. Basically, if there's a perpendicular bisector and divides it in half, this angle will be 90. Next one, this one's not that big of a deal. This one right here is very important. Say, center of circle. And we have a line going right here. This is one radii. This is the second radius. Second radius. So, what is it trying to say? Let's say we also have a line joining these 2 lines together. So what it's trying to say is that since this is equals to this, wondering why? It's because this is the radius, this is also the radius. The radius doesn't change, it's the same. These two are the same. If there's a line joining these radii, then this theta and this theta, these two angles right here, are also the same. Right? Okay. Next, we have this circle. I think I should enlarge this a bit. This looks strange. Bigger. Say we have a chord going along here. We have an angle going like this. A line going like this. A line going like this. Right, I say I have an angle right here. Let's call this angle A. And we have another line going like this, and another line going like this. Let's call this angle B. It means, what it shows here is that if two angles are formed from the same segment, right, from the same segment on the circumference, then in that case, angle A must be equal to angle B. Okay? It must be equal if they're from the same segment slash chord. Right. So let's do another one. Okay. Say from the center, right? Let's call it center O. We have the line going like this. This is a radius, by the way, radius lines. It's a line. It's a real bad looking line. We have a line going like this, a line going like this, and say we know this angle. Okay, no, we don't know, not that angle. We know we have two more jutting out from the edges like so. Right. Say we know this angle as A. This rule states that if in this position where an angle made on the center, right, and two lines being taken from these radii lines, say right here, we get two of that angle, twice that angle. If to make things much more easier, I think what is much more easier for you guys to understand is to always remember it as, say, these segments as A, B, C, and let's say the center is O. Always remember that BOC's angle will always be equals to twice the angle of BAC. Wait, what? That's what you want to know? Alright, that's basically what it's trying to say here. What it's trying to say here is, if you look at the diagram, if this is, say, A, this is twice of A. Right here. Alright. That's because it's coming from the two radii segments right there. If they're from the same segment, right? So let's do another one. This one is very important. The last one I showed you is important. This one is even more important because it's basically a major part of most of these questions. So we have a diameter right here, right? From one point of circle to the other, touching the center. An angle coming from two ends of a diameter. Let's say like that, like that. Let's say an angle like that, and like that. This angle will always be 90 degrees. No matter where it's from. It can be like this. Like this really edge thing. It can be like here. This angle is also 90 degrees. Literally, any angle like that just goes like this. Like even this and this. This is also 90 degrees. But remember this, if an angle was like from here and like this is not 90, right? This is not 90. It must be from these two last far end points. Any line, no matter what line it looks like, okay? It can look really awkward. This is 90. Right, what's next? Next one is called the cyclic quadrilateral. Exactly. So what does that say? Say we have a quadrilateral inside. It can be same-sided, it can be different-sided, doesn't matter. Let's label this as A. Let's label this as let's label this as A. Let's label this as B. Let's label this as C. This is D. It is that the opposite facing angles, say A plus B here, must be equal to 180. Okay? And here C plus D is 180. That's all you have to remember. So let's go to the semi-last rule, I think. Oh. Just like this. This way. Right. Next rule requires a little more space, so I'm going to move this away. So I'm going to show you what I mean. Say we have a line in the center, like that, and like that. And we have a line going across. It's like a kite. This is called a kite tangent. Okay, it's like a tangent line. It touches at this point and this point. It forms like a kite shape. Remember, this is 90, and I'll explain why this is 90. That's because there's a rule before this, which is I'm going to explain with this one. So I'm just going to grab this circle. Just put this in here. Say we have a line going across from here. This point here, right, it's a tangent line. Say we have a radius here, R. This line is always perpendicular, is 90 degrees. The radius and the tangent are always perpendicular to each other, right here. So that's why, in that case, in here, this is 90, this is 90. The point, if it goes from the center, it divides it equally into two halves, where if this is whole angle, this whole angle is A. This is A by 2, this is also A by 2. And over here, if this is angle B, this small part is B by 2, and this is also B by 2. Right, so let's do some maths. Finally, let's do some maths. So the first one we're going to do is, we're going to do a few easy, then work our way up across, but I think we should start with some hard maths. Or should we go easy? Let's go easy for now. Let's start with easy, okay? Because, I mean, if I randomly just give you math questions that are just way too hard for you guys to understand, it might be too annoying for you guys to answer. So, let's solve this one. Yeah, it's nice. Alright, so, let's draw a circle. We have a center point, O. Okay, we have a line. This is a radius line. This is coming from center. So point meeting the two radius points. There is a line going on the top, and a line going like there. A line going like this. Going like this. And a line going like this. The labeled angles given are, in this angle, 35. This angle, 42. Yeah. This is R, this is Q, this is P, this is S. The questions are to find 1, POS, PRS, SPQ, and PSQ. Before you do any of these, this is what I recommend. This is a life hack. Is to first just get as much of the angles from here as possible. Let's find out all of them. Right. First, we know this is also 42 because it's the radius rule. Right. This is triangle. 180 minus 42 minus 42. So let's figure that out. 180 minus 42 minus 42. 96. So this right here is 96. This must be 96 divided by 2, because you remember, if it's coming from these radius lines from the center line from here, from these radius lines, this point must be, well, this angle must be twice this angle. So we can think about this as 2x is equals to 96, so x is equals to 96 divided by 2. So 96 divided by 2 is 48. So this right here is 48. Is there any other angles we can figure out from this diagram? Let's see. Yeah, we have angles on the same segment. If this is 48, this is also 48, because this angle, if you don't notice, this angle and this triangle are from the same segment, right? From the same this segment. So this is 48, this is also 48. Right, is there any other information that we have that we can use? Let me double check. It's a good way to always check if there's any angles that you can find out, right? If not, then if you think you're ready, then okay, you're ready. Right, let's see. POS, right? POS. We already figured that out. That's 96. See, we don't have to do any calculations. This is 96. PRS. So PRS, we know that as 48. We again solved it. SPQ. SPQ. Oh, look at that. We have a different. Oh, never mind. This one, SPQ, right? So it's this angle right here. Well, we can actually find it out. We know this is 48. We know this is 42. If you're having trouble finding out the triangle, let me label it with a highlighter, I think. Yeah, use a white highlighter, yellow highlighter. It's this triangle right. If you guys can see it. See how this is 42, this is 48? So this must be, this angle right here, must be 180 minus 42 minus 48. So, minus 42 minus 48, you get 90. So this is 90. Okay, let me double check. This one actually has answers. Oh, my bad. I made a slight mistake. Wait, there is a slight mistake in my calculations. See? I make mistakes too. It's the thing I checked. Alright. I missed a line because while erasing, a line disappeared. That's why it looked so easy. It's this line right here. There is, unfortunately, a small angle difference. This tiny angle here is causing a little problem for us to not use what I just did. So to do it in a different way, we have to find this angle differently, right? So what should we do? What do you think we should do in this situation to find this angle right there? Right? Okay, if you said cyclic quadrilateral, you'll be right. If you can't see the cyclic quadrilateral, let me draw it for you, the highlighter again. It's this whole thing. It's a cyclic quadrilateral because it touches these. Oh my god, how's that triangle, dude? It touches these points right here on the circumference. That's why it's a quadrilateral, cyclic. So this angle right here and this angle right here, the angle we need to find, must be equals to 180 degrees when you add them. So the summation of these two angles right here, 35 plus 48, is 35, 8, 83, 83. So this must be 180 minus 83. So it's 180 minus 83. 97. So this is actually 7. Alright, PSQ. PSQ, right? So let's remove a bunch of this highlighter stuff. It's annoying. I have to redraw. Unfortunately, I went to the stuff. I just tried to read it. It's not a big deal though. It's pretty simple. There we go. Okay, so the next question is PSQ. 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 Right, so PSQ. PSQ. So we need to know what this angle is. So do we know any reference angles that we can use? We know this total thing is 42, right? But we don't know what this tiny portion is. You actually can't find this tiny portion as easily as you think you can. So what should we do? Well, here's an important thing that it might depend, but I don't think it will work. I can double check it though. Let me see. Oh yeah. Okay, wait. What? Is that gonna work out? Let's see. Okay, I need to know this angle. If I know this angle, I can cyclic quadrilateral to get this total angle. It's a good thing to also check certain signs to see if any matchings happen. P and Q, is there any P and Q? Wait, P dash Q. So yeah, P S Q. P S Q. Oh, okay. We're not looking for this one. P S Q. We're looking for this angle. Oh, I highlighted the wrong angle. My God, I'm an idiot. It's this angle right here. So we're gonna find this angle right here. It's a little messy, but it happens. So what is this angle, right? Well, it's actually easy. I was overthinking. We know this total angle, it's 97. So we can just 180 it completely. So 180 minus 97 minus 48. Okay, 35. Let me double check. It's good to double check to make sure. Yep, it's 35. It's 35. That is how you do this. You may think I did a bunch of figuring out towards the last part, but you may notice the first two, I did it completely without even calculating, because I already did the calculations myself, right? It's already done. That's why it's a nice trick for you to do, is to find out as much information from the diagram as possible. I think it's time we do a really challenging one to see the stark contrast between an easy question and a really, really, really hard question. But let's see. I need something that has a solution though, because I need a way to match it, or else I might be in trouble. Let's see. Yeah, let's do this one. This one looks tricky. Right. So firstly, I need to draw a circle. Let's draw a circle. Let's draw another circle right here. Two circles. This one. I have to select this. Select the circle. Select this circle. There you go. This circle is right here. So yeah. a line going from here to here, a line going straight across here. Okay, this line, this line, this line. Yeah, okay, there. This line, that, this line. Oh, I should also mention this is the center. That, um, that all the lines. Oh yeah, so this is parallel. This is parallel. This is 36. This whole thing is 1, 2, 2. This point right here is B. This is A. This is C. This is D. This is E. And this point right here is the center point. This is P. So AE is a diameter. So an important thing you must know. Let me see. Okay. These lines are parallel, right? That's good. Okay. What do I find? Oh yeah. Alright, so find BAE EED DBQ. Is that all? Yep. So what are these? So what is BAE? BAE. So first you find out what they're talking about. They're talking about BAE. Oh, I shouldn't actually do that. I'm breaking my own rules. First, let's find every single angle we can find. So what do you see? This is from center, isosceles triangle. So we know these two angles are 180. As you know, if you think what my thought process is, it's 2x plus 1 to 2. It's because these two are the same angle, so it's 2 times that. So 1 to 2 plus x plus 2x equals to 180. So x's value is 180 minus 1 to 2 divided by 2, 29. So if this is 29, this is also 29, right? This is 122 divided by 2 is because of that rule, which is that if it's coming from the edge of these radii lines and there's an angle on the center, that angle must be 2 times the angle that right here that's being formed. It must be 2 times less than this. That means basically this has to be 2 times this. This has to be 2 times this. So this has to be 122 divided by 2. 122 divided by 2. We got 61. So this is 61. Is there any other information we know? Oh yeah, this is parallel. So, wait a minute. Slide information. Okay. So we know this line is parallel. This line is parallel. That means this is also 36, right? Is there any other information we know that we need to know? Let's see. We need to go for all information, right? Oh yeah. This point right here and this point right here creates a 90-degree line. This is 90. This creates a 90-degree line. Alright. It's because ABC and APE, alright, ABC. So ABC, so it's ABC and APE are straight lines. Alright, cool, cool. Right, so for this, I'm going to take a small intermission, because I need to see the answers to be absolutely sure. Okay, so it's confirmed. Nice, I did check. Let me see if I have. Okay, so I was right. It's 90. So that line right there, that is in fact 90 degrees. So now what? Well, if that's 90, that means because this is a 180 line, this side is also 90. So if you subtract the this and this, you get the this and this, you get the angle inside, right? So what angle do you get inside? We get hold on, let me check. You get 180, no, sorry, 90 minus 36 minus, we get 25. This tiny angle here is 25. So, I think that's all. Let's start solving. BAE. So, what is BAE? BAE, it's this highlighted part. This is the angle we're trying to find out. So, what is that angle? Let me erase this. Hold on, it's not like it's supposed to erase. Go. Go. Alright, so what is BAE? What is this angle here? So, that angle, alright, how do we figure it out? Okay, we have a trick situation. What information do we know? We know that this total angle here is 90. You know, that's 36. So it's 180 minus 90 minus 36. 54. BAE is 54. That's because this here is 90. This is 36. 180 minus 36 minus 90 gives us 54. Right. Now, let's see the next one. EBD. Alright, it's a little messy, extremely messy looking right now. EBD. This angle. That's 36, because this is 36, this has to be 36 as well. So that's 36. Finally, DBQ. Oh wow, what a mess. Right, DBQ. What is DBQ? It's DB. Q is the center. Oh, I didn't like that. Alright, Q is the center, by the way. D, B, and Q. So we're looking for this data, which we found out is 25. So the answer is 25. See, just like that, you have basically all of them solved at once. Oh, I missed BDC. There's one more. My bad. I missed one more. It was also BDC. So what is BDC? Okay, let me take the highlighter. Let's find B. BDC. Oh, we know that. It's this angle, and that's 61. So, 61 degrees. Just like that. And we have solved it. That's basically most of circle theorem. A little tricky math of circle theorem. So, that's pretty much it. See you later. Bye bye. And let's get that A star.